In this tutorial, I'm going to give you some hints about how to complete a loan amortization schedule in Excel. Before we do that, however, it is important that we understand the difference between absolute and relative cell references. Let's start with a simple example. The future value of an investment earning I% interest per year is given by the equation future value equals present value times 1 plus I raised to the nth power. Down here I've created a spreadsheet to perform the calculation. We have a present value of $100 and an interest rate of 5%. These are our inputs or assumptions, which I've highlighted in yellow. Below we have our outputs, our calculations based on those assumptions. Let's go down to cell B12 and calculate our future value at the end of the first year. It's equal to our present value, $100, times 1 plus our interest rate, in this case 5%, raised to the power of n. Because this is the first year, n is set equal to 1. This equation will work fine for calculating our future value at the end of the first year, but we'll show we cannot use this equation to calculate the future value for subsequent years. Notice that the first part of the equation references cell B7, which is our present value, and inside the parentheses we have a reference to cell B8, which is our interest rate. If I copy this equation down one cell, it will not work. Now when we look at the equation, the first cell reference is no longer our present value, and the second cell reference is no longer our interest rate. What happened is, when we copied the equation down, one cell, the cell reference changed by one cell. Previously it referred to cell B7, and now it refers to cell B8. Likewise, the second cell reference here originally referred to cell B8. Because we copied it down one cell, it now refers to B9. Likewise, the third cell reference previously referred to cell A12, which was the year 1, but now refers to the year 2. Let's fix this equation so that it will work properly. We'll go back to our original equation and make two changes. The cell references we have now are called relative cell reference. If you copy a relative cell reference down one cell, the referred to cell also changes by 1. So B7 will change to B8. Likewise, this is a relative reference over here, cell B8. So if I copy it down one cell, it will now refer to cell B9. We don't want either of those things to happen. Our present value is always in cell B7, and our interest rate is always in cell B8. And so we need to lock those references into place. We can do this simply by inserting $signs in front of both the row and the column. This will ensure that if we copy the cell down, the row does not change, and if we copy the cell to the right, the column does not change. We'll do the same over here with cell B8. Put $signs in front of it so that when we copy this equation down, it always refers to the interest rate, which is in cell B8. We do not want to put absolute cell references on the cell reference for n, the number of years, because n changes each time. It changes from 1 to 2 to 3. We need that cell reference to change along with it. So now we have an equation that we can copy down and maintain our correct cell references. Let's copy it down one cell and have a look. Now when we look at the equation, it still refers to cell B7 for our present value because we put the $signs in there, and it still refers to cell B8 for our interest rate because we put the $signs in there. Notice, however, that the cell reference for n, the year, is allowed to change each time we copy the cell or equation down. So this equation can be copied to all the cells for all years and give us the correct results. Still refers to cell B7 for the present value, still refers to cell B8 for the interest rate. These are an example of absolute cell references. An absolute cell reference is created by putting the $signs in front of the row and or column. And that indicates that if we copy that cell somewhere else in our spreadsheet, the indicated row or column will not change. Now let's perform the same calculations down below, except this time we're going to spread our years horizontally rather than vertically. This will show us another problem with relative cell references. So for year 1, our future value is the present value times 1 plus our interest rate raised to the power of n. N is the first year. We'll enter our equation. We get the correct equation for the first year, but we'll see we cannot copy it to the second year and get the correct results. The reason is, of course, we did not make the first cell reference absolute. And so while it previously indicated cell B7, when we copy it to the right, it changes the column indicator now to column C. So we have C7. Likewise, on our interest rate, the cell reference should read cell B8, but instead, because we have copied it to the right and it's a relative cell reference, it now refers to column C8. The year indicator is correct. For the second year, we want to refer to cell C17. So let's fix our original equation so that we can copy it to the right. We'll go back into edit mode and we'll change cell B7 to an absolute cell reference. I'll show you a little trick here. If your cursor is inside the cell B7, you can press the F4 key at the top of your keyboard and it'll put the dollar signs in there for you. Same with cell B8. Press the F4 key and Excel will put the dollar signs in there. Cell B7 we want to leave as a relative cell reference. We want that reference to change from year 1 to year 2 when we copy our equation to the right. So now we've locked in our cell reference for the present value and for the interest rate. Those numbers will not change when we copy our cell to the right. Let's go ahead and copy to the right. Sure enough, did exactly what we wanted it to. Still refers to cell B7 for the present value, B8 for the future value, but the reference for the N, the number of years, has now changed as we wanted it to cell C17. So, get the same numbers horizontally and vertically. It is important that we understand absolute versus relative cell references and when to use them. If you want to always refer to a given cell, use an absolute cell reference. If you want a floating reference, use a relative reference. Now, let's take the knowledge that we've learned about relative and absolute cell references and apply them to the loan amortization problem. Here's our loan amortization spreadsheet, and up in the top here in the right-hand corner, I've given you the steps to take in order to complete the loan amortization schedule. So the first thing we'll do is enter our beginning balance or beginning principal for the current month. And we simply set it equal to the remaining principal from the previous month. So here we'll go. Month 1, we'll start to amortize our loan. We'll simply set the principal this month equal to the remaining principal from the prior month. Step number 2 is to calculate our loan payment. Excel has a built-in payment function equals PMT that requires a number of inputs. Excel is prompting us for the inputs. We can see the prompts down here. I prefer to use the insert function button instead. Once we've typed in equals PMT and the left parentheses, then we can click the insert function box. It'll bring up a dialog box for us showing the input rates or input variables. The first one is the rate. This is listed as the interest rate per period for the loan. The interest rate is 8%, but that's an annual rate and we're making monthly payments. And so because we're making monthly payments, we'll have to divide this number by 12. Before we proceed, however, I'm going to make this an absolute cell reference by pressing the F4 key at the top of my keyboard. This will make sure that if I copy my equation anywhere else in the spreadsheet, it still refers to the correct cell holding our interest rate. The next input is the number of periods, or the total number of payments for the loan. This is a 5-year loan with 12 payments per year. So we have 60 payments that appears up here in cell B6. Again, if I copy this equation somewhere else, I want it to always refer to cell B6. So I'll press the F4 key on my keyboard and make that an absolute cell reference. Finally, we need to know what's the present value of the loan. This is simply the loan principal, the initial amount that you borrowed. We'll click on cell B4, and then we'll hit the F4 key at the top of our keyboard and make that an absolute cell reference also. We can leave out the following remaining variables, F, V, and type. They're not needed for this particular calculation. So we'll go ahead and press the OK key, and Excel will calculate the payment for us. Now, Excel makes this a negative number to indicate that it's a cash outflow. I prefer to make it a positive number. It doesn't matter. Either way works fine. I'll just put a minus sign in front of that equation and make it a positive number. The next thing we need to do is calculate our interest paid in month 1. The interest is calculated as the beginning balance for month 1 times our interest rate. Our interest rate is 8% a year. We'll make that an absolute cell reference so that it will copy down correctly, and then we'll take that annual rate and divide it by 12 because we're only calculating the interest for 1 month. So of that $446 that we paid this month, roughly $146 of that is interest. The principal reduction, of course, is simply the amount that we paid minus the interest. So of that $446 payment, $146 is interest, and about $299 is principal reduction. That principal reduction then is used to calculate our remaining principal at the end of month 1. At the beginning of the month, we owed the bank $22,000. During the month, we paid off $299.41 on the loan. So at the end of the first month, our loan balance is now $21,700.59. We're pretty much done with our loan amortization schedule now. We can copy the first row down to the rest of the spreadsheet and amortize our loan completely. One simple way to do that is to simply click back into the first cell. If we have a column of numbers to the left and double click on the lower right corner of the cell, it'll copy the equation down for us. We can do the same for each month. Then we can look to see if we've completed our loan amortization schedule correctly. If we scroll down to the very bottom, to the 60th month, we should see a remaining principal of $0. This lets us know that we've properly amortized the loan. Let's have a look up here in row number 9. These show our totals over 60 months. So we borrowed $22,000 from the bank. We'll make payments that total $26,764. Of that amount, $4,764 was interest and $22,000 was principal. This completes our tutorial on loan amortizations.